Welcome to the exciting and ever-evolving world of ethical hacking. In this comprehensive guide, we'll delve into the fundamentals of network security by learning how to capture network traffic and meticulously analyze it for sensitive information like passwords, usernames, and other critical data. Our tools of choice? The versatile and widely used programming language Python and the powerful industry-standard penetration testing platform Kali Linux. Before we dive in, let's emphasize that hacking should always be conducted ethically and legally. This means obtaining explicit permission before attempting to access any network or device that isn't your own. Unauthorized access is illegal and unethical. The knowledge you gain here is for educational purposes, empowering you to protect your own systems and those of others with their consent. Think of ethical hacking as being like a security consultant, a professional who helps others secure their digital assets. Businesses and organizations hire ethical hackers to rigorously test their defenses and identify vulnerabilities before malicious hackers can exploit them. It's all about making the digital world a safer place for everyone. In the following sections, we'll guide you through setting up your hacking environment step by step, writing your own network sniffer using Python to capture and analyze data packets, and utilizing Kali Linux's built-in tools for deeper, more advanced analysis. Let's get started on this exciting journey. Kali Linux is the go-to operating system for security professionals and enthusiasts alike. This Debian-based distribution comes preloaded with a vast arsenal of security tools, making it the perfect platform for our exploration into network hacking. First, you'll need to download Kali Linux from the official website. You can choose to install it directly on your computer or run it in a virtual machine. For beginners, a virtual machine is recommended as it provides a safe and isolated environment to experiment without risking your main operating system. Once Kali Linux is installed, boot it up, and you'll be greeted with a familiar desktop environment. Open a terminal window, our gateway to the command line tools that make Kali so powerful. With Kali Linux up and running, we're ready to equip ourselves with the programming prowess of Python. Python's readability and extensive libraries make it an ideal language for network programming and security tasks. We'll be using Python to create a network sniffer, a program that captures and analyzes network traffic passing through your computer. Don't worry if you're new to Python, we'll guide you through the essentials. First, ensure that Python is installed on your Kali Linux system by typing in the terminal. Kali Linux typically comes with Python pre-installed. The key Python library we'll be using is. This library provides the necessary tools for working with network sockets, the endpoints of network communication. We'll use the library to capture raw network packets, the fundamental units of data transmitted over a network. In the next section, we'll combine our knowledge of Python and the library to craft our network sniffer. Let's open up a text editor and start writing our Python sniffer. First, we'll import the library import socket. Next, we'll create a socket object and bind it to a specific network interface. This tells our sniffer which network interface to listen on for traffic. We'll use the address family for IPv4 and socket type to capture raw packets. s=socket.socket, socket.af_inet, socket.sock_raw, socket.iproto_tcp. Now we'll enter an infinite loop to continuously capture network traffic, while true inside the loop we use to receive data from the socket. The argument specifies the maximum buffer size for receiving data. We've now laid the foundation for our Python sniffer, capturing raw network packets. Section 5. Understanding packet analysis. In this section, we will delve into the intricacies of how data travels across networks and how we can interpret this data. Raw network packets are like envelopes containing various pieces of information. Each packet carries a small piece of the overall data being transmitted. To make sense of this data, we need to understand the structure of network packets. This structure is crucial for identifying and analyzing the data effectively. This is where packet analysis comes in. It allows us to dissect these packets and understand the flow of information. Network packets are typically structured in layers, with each layer serving a specific purpose. These layers work together to ensure data is transmitted accurately and efficiently. The most common model for understanding network protocols is the TCP/IP model. This model is fundamental in the field of networking. It consists of 4 layers, each with its own unique function and responsibility in the data transmission process. Application layer handles user-facing data such as web pages, HTTP, email, SMTP, and file transfer, FTP. This layer is closest to the end user. Transport layer provides communication between applications on different hosts. TCP and UDP are the most common protocols at this layer. They ensure data is sent and received reliably. Network layer, responsible for routing packets across networks, IP or Internet protocol, operates at this layer. It determines the best path for data to travel. Link layer handles the physical transmission of data over the network medium like Ethernet and Wi-Fi. This layer is essential for the actual movement of data. By understanding the structure of network packets, we can extract valuable information, including source and destination IP addresses, port numbers, and even the data payload itself. This knowledge is vital for network troubleshooting and cybersecurity. Section 6. Deploying your Python Sniffer. With our Sniffer ready, let's put it into action. Save your Python script and then run it from the terminal using the command. As the Sniffer runs, it will capture network packets and display them in the terminal. You'll see a continuous stream of hexadecimal data representing the raw packet content. 0000FFFFFFFF001, CC 4115608080028, V 001006080400010001, CC 4115608010000, V 00200000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 This raw data might seem overwhelming at first, but don't worry. We'll use Kali Linux's tools to make sense of it. Section 7. Wireshark, a cybersecurity Swiss Army knife. Wireshark is a powerful and widely used network protocol analyzer. It allows us to capture, filter, and inspect network traffic in a user-friendly interface. Think of it as a microscope for your network. Wireshark comes pre-installed on Kali Linux. To launch it, simply type in the terminal. You'll be presented with a window listing the available network interfaces on your system. Select the interface you want to capture traffic on and click Start. Wireshark will begin capturing packets in real time. You'll see each packet listed with details such as the source and destination IP addresses, protocol, and packet length. Section 8. Extracting passwords from captured data. Now the exciting part. Extracting passwords from the captured network traffic. Keep in mind that ethical considerations are paramount. Only analyze traffic that you have permission to access. Wireshark makes it relatively easy to filter for specific types of traffic that might contain passwords. For example, you can filter for HTTP traffic, port 80, to look for unencrypted login credentials transmitted over plain text. Right-click on a captured packet and select Follow TCP Stream. This will display the entire conversation between the client and server. If the communication is unencrypted, you might find passwords in plain text within the data. It's important to note that modern websites and applications rarely transmit passwords in plain text. They use encryption protocols like HTTPS port 443 to secure sensitive information. Section 9. Ethical considerations and further exploration. Congratulations, you've learned the basics of network hacking, from crafting a Python sniffer to capturing and analyzing network traffic using Kali Linux and Wireshark. These foundational skills are crucial for any aspiring cybersecurity professional. Remember that these skills are to be used responsibly and ethically. Misuse can lead to serious legal consequences and harm. This is just the tip of the iceberg when it comes to cybersecurity. The field is vast and constantly evolving. There's a vast world of knowledge to explore, from cryptography and penetration testing to malware analysis and incident response. Each area offers unique challenges and opportunities. Continuously learning and experimenting in a safe and ethical environment is key to becoming a cybersecurity professional. Stay curious and keep pushing your boundaries. Here are some resources for further learning. Platforms like Coursera, Udemy, and Cybrary offer comprehensive cybersecurity courses. These platforms provide structured learning paths and hands-on labs. Industry-recognized certifications like CompTIA Security Plus, CEH, Certified Ethical Hacker, and OSCP, Offensive Security Certified Professional, can enhance your credentials. They validate your skills and knowledge. CTFs are online competitions that challenge your cybersecurity skills in a fun and engaging way. They simulate real-world scenarios and test your problem-solving abilities. Remember, the best way to learn is by doing. Practical experience is invaluable. Set up a virtual lab, experiment with different tools and techniques, and practice regularly. Never stop exploring the ever-evolving world of cybersecurity. Stay updated with the latest trends and advancements to keep your skills sharp.